Section 2.2 Basic Differentiation Rules and Rates of Change. In 2.1, you learned the definition of derivative, which is kind of tedious process to find f prime of x. However, so many functions will follow the same pattern of derivatives, so we will learn them as rules to find the derivative of many functions, and that will save our time a lot. So here are basic derivative rules. First rule is constant rule. For any real number c, derivative of constant is 0. Why is that? Well, constant is y equals c, and y equals c is a horizontal line. And as you know, derivative is the slope function. And if you have a horizontal line, slope of a horizontal line is always 0. So derivative of any constant will be equal to 0. So let's see if we can do those examples. What is the derivative of negative 12.54? That's just a constant, right? So derivative of negative 12.54 is 0. Do you see any other constant in this example? I see it right here. It looks like a variable to the second power, but pi is just a number. It is an irrational number that does not terminate. So it is a number, and number squared is a number. So you do have a constant here. So derivative of pi squared will be also equal to 0. Do you see any other constant here? Yes, we do have one more. Derivative of 1 over square root 3. That's a constant. So therefore, derivative of 1 over square root 3 will be also 0. All right, and let's move on to the next rule. Next rule is called the power rule. So let's say n is any real number, and if you have a power function x to the nth power, then to take the derivative of that, you can bring the n down. So n become constant multiple of your variable, and you lose one power. So you need to subtract 1 from your original power. That's what the derivative will become. I have an example right here for the power function. You can see I have x to the power 7. So derivative of that, what do? You just need to bring the power down to the front. So 7 comes down to the front and become constant multiple of your power function. And now you're gonna lose one power from 7. So now it become power 6. That will be derivative of that. Now, how about any other power function do you see? Any other power function? I do see this one. It doesn't look like a power function, but if you rewrite 1 over x to the third power, it is x to the negative third power. Is that a power function too? Well, they said n be any real number. So power can be any real number. So it's okay to be negative number as well. Now I can apply the power rule here too. So you can bring the power down to the front. So you're gonna get negative 3 times x to the, remember, you lose one power. You always need to subtract 1 from the original power. So that will become negative 3 x to the negative power 4. So then simplify. We never leave negative exponent answer like that. So your answer is going to be equal to negative 3 over x to the positive power 4. That is the answer of this question. I also see right next to, I have a derivative of a square root of x. And every radicals are rational exponent. We can always change it to rational exponent. So let's change this to an exponent. So then I have derivative of, what is the square root of x when you change it to rational exponent? It is x to the 1/2 power. So according to the rule, you're gonna have to drop the power down to the front. So it's gonna become 1/2 times x to the, what do? Whatever the power you had, you need to subtract 1 power from it. So that will be 1/2 x to the 1/2 minus 1 is negative 1/2. we cannot leave negative power as an answer. So that will be 1 over 2, and x to the negative 1/2 power goes to the denominator. So x to the positive 1/2 power, and positive 1/2 power is radical x. So that will be the answer. So derivative of the square root of x is 1 over 2 square root of x. All right, now third rule is constant multiple rule. So let C be any real number, and derivative of a constant multiple times a function, you can just leave the constant in the front and just take the derivative of your function and multiply by it afterwards. So for example, if you look at this example right here, derivative of 3/4 x, that's a constant multiple 3/4 times x to the power 1. You don't see any power, but when you don't see any power of your variable, then it is power 1. So you can still use the power rule. So that will be, according to the rule, I'm just gonna leave the 3/4 in the front and just take the derivative of x to the power 1. X to the power 1 comes down to the front, and I need to lose 1 power, which is equal to 3/4 x to the zeroth power. And what was any variable to the zeroth power? Yes, it is 1. So this will be 3/4 times 1, which is equal to 3/4. But this one, it comes a lot because a lot of functions are linear functions. So now you know if you have a linear function, y equal mx, then your derivative will be just m, right? Because that's what the slope of line is. So if you have a y equal mx, the m designate the slope, and since we're trying to get a slope function here, you're just gonna get this constant derivative function for your linear function. Next, last problem here that we haven't done yet is also constant multiple times the power function. How is that a power function? It's a cube root of x. That's right, but remember we just said any radical functions, we can convert it to the rational power function. So let's change this to power function. So this is dx of 6 times x to the, what's the cube root of x? That will be 1/3 power, which is equal to, that will be this rule right here. Yeah, I have a constant multiple 6, so leave the 6 in the front, and now I need to use the power rule to the x to the 1/3 power. And power rule was you bring the power down to the front, and then you lose 1 power from the original power. So then 6 times 1/3, it get canceled, right? 3 goes there once, 3 goes there twice. So now you have 2 times x to the, what power is that? That will be 1/3 minus 1, which is negative 2/3 power. And because I cannot leave negative exponent as an answer, I'm going to change it to positive exponent. So x to the negative 2/3 will go to the denominator. So I have a 2 over x to the 2/3 power. And 2/3 power, you can change it to radical notation. So you can have a 2 over cube root of x squared. Next, the sum and difference rules. Let f and g be differentiable functions. Then derivative of fx plus g of x is equal to f prime of x plus g prime of x. Likewise, derivative of fx minus g of x will be equal to f prime of x minus g prime of x. So if you have a multiple terms that you have to take the derivative of, you can just take the derivative each term by term. So let's go ahead and do an example. Find each derivative. I have 6 radical x cubed minus 8 over square root of x. So it's always a good idea to change them to a power function so we can use the rules that we just learned. So let's change them to a power. So derivative of 6 times x to the square root of x to the third, when you change it to rational exponent, it will be 3 over 2 power minus 8 times Square root of x is x to the 1/2 power, but because it's in the denominator and we need to bring it to numerator, so that will become negative 1/2 power. So now we take the derivative of each term. First one, I will leave constant multiple in the front, bring the power down, and I lose 1 power from 3 over 2. So I will get 1/2 power minus constant multiple 8 times, bring the power down, and I lose 1 power, so negative 1/2 minus 1 gives me negative 3 over 2 power. Now we can just clean it up. 2 goes there once, 2 goes there 3. 3 times 3 is 9, x to the 1/2 power. Negative times negative give me positive. 2, 1, 2, 4. 4 times 1 is 4, x to the 3 over 2 power. X to the negative 3 over 2 power. Now, in chapter 3, we always need to factor these derivatives out to find what's called a critical number. So might as well start practicing it. So let's factor this out. So we learned that we always factor out the smallest power, and smallest of 1/2 power and negative 3/2 power will be negative 3/2. So you factor out x to the negative 3/2 power, open, 9x to the, remember the power rule, a to the mth power times a to the nth power is a to the m plus nth power. So when you think about this power, you have to think that negative 3/2 power plus what over 2 gives me 1 over 2. So that will be 4 over 2. But what is 4 over 2? Power 2. So that's a 9x squared plus, since the whole x to the negative 3/2 power is out, you only have a 4 there. And because we cannot leave a negative exponent answer, my answer will be 9x squared plus 4 over x to the 3/2 power. And that is your final answer for this problem. Let's do the next one. Derivative of 9 over 2x to the 4th plus 1/3 x squared minus 4 over x equal to, again, let's rewrite them so that it's easier to take the derivative of. And that's equal to 9 over 2 is a constant multiple, so you can pull out as a 9 over 2. Since x to the 4th power is in the denominator, when you bring it to the numerator, it's going to become negative power. 1/3 x times 1/3 x will give you 1 over 9x squared minus constant multiple 4 times. When you bring x to the numerator, it's going to become negative exponent. It's all now ready to take the derivative of each, and you will use power rule for all of it. So this is equal to, I have a constant multiple 9 over 2. I'm going to bring down the power and lose 1 power from it. I get negative 5th power now, plus constant multiple 1 over 9th. Power comes down. I lose 1 power, minus 4 times. Bring the power down. I lose 1 power. I get x to the negative 2nd power. So now I clean it up. 2 goes there once, 2 goes there negative twice. 9 times negative 2 is negative 18. X to the negative 5th power plus 1 over 9 times 2 is 2 over 9 x. Negative 4 times negative 1 is positive 4 x to the negative 2nd power. But I would like to factor and get rid of negative exponent. So factor out 2 over 9. Why 2 over 9? Well, every coefficient is a multiple of 2, and I don't want a fraction inside of my parentheses. And with x to the negative 5th power and the x and x to the negative 2nd power, what is the smallest power of x? That will be x to the negative 5th power. So you take that out. So then 2 over 9 times, then first factor is we took 2 out, so 2 times negative 9 is negative 18, but we also divide by 9, so we need to undo that, which is multiplying by 9. So negative 9 times 9 will give me negative 81. Notice that I took the whole x to the negative fifth out, so I won't have any power of x there, and plus 2 over 9, 2 over 9 out, and for the power of x part, x to the negative fifth plus what is a positive 1 power? That will be x to the power 6. So the negative 5 plus 6 gives you power 1 plus 2 times 2 is 4, so there's a 2, but then you divide by 9, so undo that, you need to times by 9. 2 times 9 will give you 18. X to the negative fifth power times x to the what power gives you x to the negative second. Negative 5 plus 3 gives you negative second power. So this will be power 3. All right. Well, what's inside of a parenthesis is a polynomial, but it's out of order. So let's write that in descending order. And when we write the final answer right now, let's also bring down negative exponent to the denominator. So I have a 2 in the numerator, and if I write my polynomial factor inside of a parenthesis to descending order of a power, I will have x to the 6th plus 18x to the 3rd power minus 81 over, I had a factor 9 already. X to the negative 5th power comes down and become x to the positive 5th power. So this will be simplified answer for this problem. Now we're going to find out what's the derivative of a sine function is and derivative of a cosine function is. And in order to derive derivative of sine x and derivative of cosine x, we need quite a knowledge here. First of all, we need these special limits that we learned from section 1.3. We call limit x approaches 0 of sine x over x is equal to 1. Limit x approaches to 0 of 1 minus cosine x over x equals 0. And we also need our trig knowledge here. From trigonometry, we learned that sine of angle A plus B is equal to sine A times cosine B plus cosine A times sine B. Cosine of A plus B is equal to cosine A times cosine B minus sine A times sine B. Also, algebra review, y minus x can be always rewritten as opposite of quantity x minus y. And you can also think this as you are factoring out negative 1 from this original expression, so that negative x become positive x and positive y become negative y. Same thing. So let's go ahead and derive derivative of sine x. So derivative of sine x is equal to, we're going to of course use our famous limit definition of derivative. So that will be limit delta x approaches to 0 of, what is our function right now? Our function is sine x, right? So that will be sine of input, and my input is x plus delta x. So it will be sine of x plus delta x minus sine of x over delta x. Now I'm going to use this sum formula for the sine. So that will be equal to limit delta x approaches to 0 of sine x times cosine delta x plus cosine x times sine delta x minus sine x over delta x. Notice that you have sine x in this term, and also this term has the sine x as well. The middle term do not have a sine x. So in next line, we're going to factor out the sine x and write as a 2 term on the numerator. So now I have a limit delta x approaches to 0, factor out sine x I have a cosine delta x minus 1 plus cosine x sine delta x over delta x. Note that a over b plus c over b is a plus c over b, vice versa. So when I have multiple terms on the numerator, I can always split the fractions using the same denominator. So I would like to split this limit to two rational expressions because I see that each of these fractions contain one of these each, so that we can use this limit. So let's go ahead and now split this. So I have a limit delta x approaches to 0. However, I can see that we have 1 minus cosine x over x equals 0, not cosine delta x minus 1 over delta x. So I need to have this parenthesis switched. So this is when I'm going to use this algebra fact. So let's go ahead and rewrite it and split the fraction. So then I will have negative sine x 1 minus cosine delta x over delta x plus limit delta x approaches to 0 of cosine x sine delta x over delta x. Also, I could look at this as a product of two functions and split these each. So this will be, remember, limit of a product of two functions is product of limits of each of functions. So I will have limit delta x approach to 0 of negative sine x times limit delta x approaches to 0 of 1 minus cosine delta x over delta x plus limit delta x approach to 0 of cosine x times limit delta x approaches to 0 of sine delta x over delta x. So you notice that my delta x, delta x, delta x matched up. So this limit indeed is equal to 0, like we said here. And here's delta x, delta x, delta x matched up. So I could also use this limit perfectly here as well. And what is the limit delta x approach to 0 of negative sine x? Well, there's no delta x in this expression for you to send it to 0. So limit of negative sine x as delta x approaches to 0 is just negative sine x times this limit is 0 plus limit delta x approaches to cosine x is just cosine x times limit delta x approaches to 0 of sine delta x over delta x is 1. And this is 0 since 0 times anything is 0. So I get cosine x. So you just found out derivative of a sine function is cosine function. Derivative of sine x is cosine of x. Now that we have driven derivative of sine x, deriving derivative of cosine x will be piece of cake. Let's do it again, guys. So derivative of cosine x is by definition limit delta x approaches to 0 of cosine of x plus delta x minus f of x is cosine x all over delta x. Use trig identity. Cosine of x plus delta x will be cosine x times cosine of delta x minus this time sine x times sine delta x. This is what's the cosine of x plus delta x is, minus cosine x all over delta x. Do you remember what we did last time? So look at your numerator and you can see that this guy have a cosine x factor, this guy have a cosine x factor. So you could put them together and factor out the cosine x, but that will leave you cosine delta x minus 1. But we want 1 minus cosine delta x over delta x, remember? We have done it once. So let's go ahead and factor out negative cosine x. So limit delta x approaches to 0 of, we're gonna factor out negative cosine x. And if you factor out negative cosine x from here, you can have a 1 minus, And from this part, you're gonna get cosine of delta x minus sine x times sine delta x all over delta x. We will split this now. So then this is the same as limit delta x approaches to 0 of negative cosine x times 1 minus cosine delta x over delta x minus limit delta x approaches to 0 of sine x times sine delta x over delta x. Now we can also split this product. So you have limit delta x approaches to 0 of negative cosine x times limit delta x approaches to 1 minus cosine delta x over delta x minus limit delta x approaches to 0 of sine x times limit delta x approaches to 0 of sine delta x over delta x. So now we can use a special limit formula. This, when limit delta x approaches to 0, this expression negative cosine x has no delta x in it. So limit of that will be just negative cosine x times limit of this is equal to 0 minus limit delta x approaches to 0 of sine x is just sine x, and then limit delta x approaches to 0 of sine x over delta x is 1. So this becomes 0 and I get negative sine x. So we just derive the derivative of a cosine x and it is negative sine x. So again, what is it, guys? What's the derivative of sine x? It will be cosine x. And what is the derivative of a cosine x? That will be negative sine x, and we will just use it without deriving unless I ask you to derive on the test. Then you have to show me the whole thing. But if it doesn't say to derive, then you are free to use derivative of sine x is just directly cosine x, and derivative of cosine x is negative sine x, like formula or rules. Let's do an example. Find each derivative. What's derivative of x plus pi over 2 cosine x? So this will be equal to derivative of x plus derivative of pi over 2 times cosine x. And what is derivative of x? That will be just the slope 1. So that is 1 plus derivative of scalar multiple times a function. We leave the scalar multiple in the front, and now just to take the derivative of cosine x. And derivative of cosine x, as we just learned, is negative sine x. So our answer will be 1 minus pi sine x over 2. And if we would like to make a single expression, that will be 2 minus pi sine x over 2. How about derivative of 3 over x minus 7 sine x? That will be equal to derivative of 3 times x to the negative 1 power minus derivative of 7 sine x, which is equal to constant multiple times. Power comes down to the front, so negative 1 times. We lose 1 power, so negative 1 minus 1 become negative second power minus derivative of 7 sine x. We leave constant multiple 7 in the front and take the derivative of sine x, which we just learned as cosine x. When we clean this up, I have negative 3 over x squared minus 7 cosine x over 1. To have a common denominator, we would multiply top and bottom by x squared. So your final answer will be negative 3 minus 7x squared cosine x over x squared. Alright guys, that's it for part 1, and I will see you again in part 2.